In this video, I will show you how to solve rational inequalities such as this one, and this one, and this one, and this one. First, we need to find the critical values. The critical values are going to come from two sources. We will get one set of critical values by solving the related equation, and we will get another set of critical values by considering the illegal values. So look, here's how it really breaks down. We're going to get one set of critical values out of the numerator, because the way you solve this equation is by setting the numerator equal to 0. We'll get another set of critical values from the denominator. That's really how this is going to break down for a simple problem like this one. So critical values. From the numerator, I'm going to get x is equal to 7. All right, that's one critical value. And from the denominator, I'm going to get x cannot equal 1. So these are my two critical values. Okay, so here I go. So here's 1, and here is 7. So the illegal value, x cannot equal 1, that's going to be an open circle no matter what. The other one depends on whether or not there's an or equal to sign here. So since I just want values that are greater than 0 but not equal to 0, this one will actually be an open circle as well. Oh God, didn't mean to go dark. All right, so I need to check these intervals. So over here in the first interval, let's just do f at 0. In the second interval, I'm going to do f at 2. And in the third interval, I'll do f at 8. Okay, so 0. Look, if I put 0 here and here, that's just going to be positive 7. Okay, so I get positive 7 is greater than 0. That's a yes. That means I have solutions in this interval. Well, that was easy. Now I'll check 2. That would give me 2 minus 7 over 2 minus 1 is greater than 0. So that's going to be negative 5 over 1, which of course is just negative 5. That's a no. That's a no. So there will be no solutions in that interval. And finally, I will check f at 8. So that would be 8 minus 7 over 8 minus 1. And is that greater than 0? Well, that would be 1 over 7. That is true. That's a positive number, so that's a yes. So that means I do have solutions in this interval. So in interval notation, my final answer would be negative infinity to 1 with parentheses, open circles, you see, and then 7 to infinity. So this should be the answer in interval notation for number 1. Okay, again, I need to find my critical values. My critical values will come from setting this whole thing equal to 0 and solving. And my critical values will also come from the illegal values. Well, to solve an equation like this, you just set the numerator equal to 0. So that's going to give me x equals negative 5 right away. So that's one critical value. Now I'm looking for the illegal values. 4. X cannot equal 4 because that would cause a 0 denominator. So this is also a critical value. So these are my two critical values. All right. So number line. I've got negative 5 and I have positive 4. Now, open circles or closed circles? That's my next question. The illegal values have to be open circles for sure because they're illegal, they can't be included. The other value is going to depend on whether or not there's an or equal to sign. So this will be a closed circle at -5. So it's time for me to test each interval. In the first interval, I will check f at -6. In the middle interval, I will check f at 0. And in the last interval, I will check f at 5. So let's start with -6. So this will be -6 plus 5 over -6 minus 4. And is that less than or equal to 0? Well, that would be -1 over -10, which is +1/10. Is that less than or equal to 0? No, that's a positive number. So I'll have no solutions in this interval. Next, I'm going to check 0. If I put 0 here and here, that's going to give me -5/4. And the question is that less than or equal to 0? Well, yes it is. It's a negative number. That means that I will have solutions in this interval. And finally, I'm going to check f at 5. So this would be 5 plus 5 over 5 minus 4 less than or equal to 0. Well, that's 10 over 1. Is that less than or equal to 0? No, that's a positive number. No solutions in that interval. So, time for interval notation. It should be -5 to 4, bracket, parentheses. All right, number 3 is going to take a little bit more work because I don't have 0. I'm going to start by moving this 3 over to the left, subtracting 3 from both sides. So I'm going to have x plus 32, okay, over x plus 6, minus 3 is less than or equal to 0. Okay? Now, I need to start by solving the related equation, though, and I need like denominators to solve this equation. So I need an x plus 6 in the numerator and the denominator. That way I have like denominators. And once I have like denominators, I can cancel these out. Okay, and right now I'm pretending this is an equation. So that's going to give me so I've got x plus 32 minus 3 times x plus 6 is equal to 0. Now be careful when you distribute this. It looks like a 3. This is really a -3. So that's what I have to distribute. So I'm going to have x plus 32, but then I'll have minus 3x minus 18. A common mistake is to put positive 18 right here, but -3 times 6 is -18. So combining like terms, I'm going to have -2x, and then what's this going to be? I can subtract 14 from both sides, so that's -2x is equal to -14, and then I'll divide both sides by -2, and I will get x is equal to 7. Okay, so this is one critical value, x is equal to 7, but it's not the only critical value. There's also illegal values. X cannot equal -6 because that would cause a 0 denominator. So these are my 2 critical values, and they both go on a number line. Alright, so here comes my number line Okay, with negative 6 and 7. Okay, so here's negative 6, and here is 7. The illegal values will always be open circles. So I'm going to have an open circle at negative 6. The other value depends on whether or not it's or equal to. Because this is less than or equal to, the 7 should be a closed circle. All right, so now I need to test each interval. For example, let's check f at negative 7. Let's check f at 0. And let's check f at 8. You know what? I like to color coordinate these. So let's see, f at 0. F at 8. Okay. So I'm going to check f at negative 7. I am going to use this version of the problem, okay, without the red part. All right, this is the version I'm looking at. Okay, so when I do negative 7, I'm going to have negative 7 plus 32 over negative 7 plus 6 minus 3. And the question is that less than or equal to 0? So this is going to be 25 over negative 1 minus 3. So that's going to be negative 25 minus 3, which is going to be negative 28. So obviously, yes, that is less than or equal to 0, which means that I will have solutions in this first interval. Okay, now for the 0, 1, if I put 0 in for these x's, I'm going to get 32, oh, that's too big. All right, if I put 0 in for these x's right here, that's going to give me 32 over 6 minus 3 is less than or equal to 0. Okay, this is going to be 5 point something. 32 divided by 6 is 5.3. So 5.3 minus 3 is going to be 2.3, approximately. What matters is that this is a positive number, so that is not going to be less than or equal to 0. So that's a no. So there will be no solutions in this interval. All right, so last I need to check f at 8. Okay, so that's going to be 8. Just going to squeeze it in here. That's going to be 8 plus 32 over 8 plus 6 minus 3 is less than or equal to 0. So that's going to be 40 over 14. Okay, let's see, 40 divided by 14. So that's 2.8. Okay, so what matters is that this is going to be a negative number. So that definitely is going to be less than or equal to 0. So that's a yes. So I will have solutions in this interval. You all right, Adiz? So in interval notation, that's going to give me negative infinity to negative 6 with parentheses, union 7 to infinity with a bracket. All right, problem number 4. I need to start by moving this 5 over to the left. So that's going to give me x plus 68 over x plus 8 minus 5 is greater than or equal to 0. All right, but the first thing I need to do is I need to solve the related equation where this is equal to 0. And the way I solve an equation like that is I do like denominators. So I'm going to have x plus 8 in the numerator and the denominator, like this. Once I have like denominators, I can cross them out. So I can go like this, and I'll get a new equation that goes x plus 68 minus. Now be careful, when I do the distributive property, this is a negative 5. In fact, maybe I'll just show one more step. Okay. We are distributing a negative 5. So this is going to be x plus 68 minus 5x minus 40. Not plus 40, minus 40. So combining like terms, we're going to have negative 4x plus 28 is equal to 0. And then I'm going to subtract 28 from both sides. So I'll have negative 4x is equal to negative 28. And then dividing both sides by negative 4, I get x is equal to 7. So this is one critical value. But the other critical value comes from the illegal value here. X cannot equal negative 8. All right, so these are the critical values that need to go on my number line. All right, so here comes the number line. Okay, so here's negative 8, and here is 7. The illegal values are always going to be open circles, so I'll have an open circle here. The other value depends on whether it's greater than or equal to. Because of the or equal to, the 7 should be included with a closed circle. So now I need to check, I need to test each interval. So let's check f at negative 9. And in the middle interval, I will check f at 0. And in the final interval, I will check f at 8. Okay, so let's start with negative 9. As I do this, this is the version that I'm looking at, guys. You know what, I should switch this back to an inequality again, though. All right, it was greater than or equal to 0. All right, this is the version that I'm using. So that's why I'm going to have negative 9 plus 68 over negative 9 plus 8 minus 5 is greater than or equal to 0. So that's going to make 59 over negative 1. So this is really negative 59 minus 5. So this is negative 64. Is that greater than or equal to 0? No. is not. So I will have no solutions in the first interval. Next, I'm going to check and see what happens at 0. At 0, if I put 0 in for these x's, I'm just going to have 68 over 8 minus 5 is greater than or equal to 0. Okay. 68 divided by 8 is 8.5. So I've got 8.5 minus 5. Okay, so that's going to be 3.5. That's definitely greater than 0. It's positive. So that's a yes. So that means I have solutions in this interval. All right, now I just need to check 8. So that's going to be 8 plus 68 over 8 plus 8 minus 5. And is that greater than or equal to 0? Okay, so this is going to be 76 over 16 minus 5. And that gives me 4.75 minus 5. What matters is that this is going to be a negative number. All right? So I'm going to get a negative number. So is that going to be greater than or equal to 0? No. So I will have no solutions in that interval. So that means this is a graph of the solution set. So I can go ahead and write my final interval notation, which would be negative 8 to 7, parentheses, bracket. So to solve number 5, we need to solve the related equation, treating this like an equal sign. But really, to solve this, you can cancel out the denominator immediately. So I'm really just going to have x plus 3 times x plus 5 is equal to 0. So if I solve this, I'm going to get x equals negative 3 and x equals negative 5. So those are two of my critical values. But in addition to that, when you have a rational inequality, you have to worry about illegal values, because those are also critical values. So x cannot equal negative 2, because that would cause a 0 denominator. So these are my critical values. So I'm going to put all of these on my number line. Okay, so I've got negative 5 and negative 3 and negative 2. Let's decide if these should be open circles or closed circles. Well, the illegal value automatically has to be an open circle because it's illegal. The other two depend on whether or not this is greater than or equal to. Because it's greater than or equal to, these two values should be included. So we'll put a closed circle. Now we need to decide which values we're going to test. In the first interval, I'll do f at negative 6. In the second interval, I'm going to do f at negative 4. In the next interval, I'm going to have to do a decimal here. Fine. Be that way. F at negative 2.5. And in the final interval, I'm going to do f at 0. I like to color coordinate this. But I always forget. So what did I say? Negative 4 and negative 2.5. Okay, let's see what we've got. Okay, so with the negative 6, I'm going to have negative 6 plus 3, negative 6 plus 5, negative 6 plus 2. And is this greater than or equal to 0? That's the question. Well, that is going to be a negative number times a negative number divided by a negative number. All right, so that's going to be a positive divided by a negative. So that's going to be a negative. So that's a big old no on that one. All right, negative numbers are not greater than or equal to 0. So I'll have no solutions in that first zone. Okay, how about negative 4? So that would be negative 4 plus 3, negative 4 plus 5, negative 4 plus 2. And we're asking if that's greater than or equal to 0. Well, that would be a negative number times a positive number divided by a negative number. Okay, so that's going to be a negative number divided by a negative number, which is a positive number. So that's a yes. Positive numbers are greater than or equal to 0. So I will have solutions in this interval. Now I need to check negative 2.5. So that'll be negative 2.5 plus 3, negative 2.5 plus 5, and negative 2.5 plus 2. So that is going to give me a positive number times a positive number divided by a negative number. Well, that's a positive number divided by a negative number, which equals a negative number. So that's going to be a no. So there will be no solutions in that interval. And finally, checking the 0. If I put 0 here and here and here, okay, then that's going to give me 3 times 5 over 2. All right, those are all positive numbers, so that's going to be a yes. So I will have solutions in this interval. So this is a graph of my solution set. I'm ready for interval notation. So my final answer is going to be bracket negative 5 to negative 3 bracket union parentheses negative 2 to infinity. Okay, so for problem number 6, the first thing I need to do is factor this denominator so I can see what I'm dealing with. So in factored form, this is going to be, so I've got x plus 6 over 3 times 8. Okay, I need a negative 5 middle, so I'll go with negative 8 and positive 3. Okay, great. So I factored it. Now, I need to start by solving the related equation. So I'm going to temporarily pretend this is an equal sign. So the way you solve a rational equation like this one, if all you have is a single fraction, all you really do is set the numerator equal to 0. So all I'm really going to do is I'm going to set x plus 6 equal to 0. And that's going to give me x equals -6. Okay, so that is one critical value that I'm going to have. Now, I'm also going to get critical values from the denominator because of illegal values. Because of the x plus 3, x cannot equal -3. Because of the x minus 8, x cannot equal +8. So I have these three critical values. So once you have your critical values, you make a number line out of them. Okay, let's see. I want to put them in order. So I've got -6, -3, and 8. Okay, so here's -6, here's -3, and 8. So these critical values, first of all, we have to ask ourselves, are they going to be open circles or closed circles? Well, the illegal values are automatically open circles because they're illegal. They cannot be included. So I'll definitely have an open circle at -3 and 8 because those are illegal. The other value, well, it depends. It depends on if it's greater than or equal to. Because of the or equal to, the -6 will be included, so we'll put a closed circle there. Next, we need to test each one of the intervals created by the critical values. So in the first interval, I'm going to pick -7. In the second interval, I'm going to pick -2. In the third interval, I'm going to pick 0. And in the fourth interval, I'm going to pick 9. All right, I need to check all of these. All right. Okay, -7. So that's going to be -7 plus 6 over -7 plus 3 over -7 minus 8. And the question is that greater than or equal to 0? All that really matters is the signs. So I'm going to have a negative in the numerator, and then I've got a negative times a negative. All right, well, that's a negative divided by a positive. So that's a negative. Is a negative going to be greater than or equal to 0? No. So that means that there are no solutions in that first interval. I had made a mistake when I said -2 for this interval. -2 is not between -3 and -6. I should have been saying like -4 or -5. So let's go with that. So that's going to give me -4 plus 6 over -4 plus 3, -4 minus 8. And we're asking if that is greater than or equal to 0. Well, that's going to give me a positive over a negative times a negative. That's going to give me a positive over a positive. All right, which of course is a positive. So yes, a positive number is going to be greater than or equal to 0. So we will have solutions in this interval. Okay? if I substitute in 0, that's going to wipe out these x's. And that's just going to leave me with 6 over negative 24. So I'm going to squeeze that in right here. 6 over negative 24. Is that greater than or equal to 0? No, that's negative 1/4. So that is not greater than or equal to 0. So there will be no solutions in this interval right here. And then finally the 9. So that would be 9 plus 6 over 9 plus 3 times 9 minus 8. And we're asking if that's greater than or equal to 0. So that's going to be a positive over a positive times a positive. Okay, so obviously that's going to be a positive result. So that's another yes. So I will have solutions in this interval. All right, so now we're ready to write our interval notation for problem number 6. So this should be bracket -6 to -3 parentheses union parentheses 8 to infinity. All right, so that is the final answer for number 6. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.